The longest waves on the electromagnetic spectrum, radio waves, carry information from a station to a receiver. But radio waves don't carry information all by themselves. They need to be altered, or modulated. A signal, a transverse sound wave, overlays the carrier wave, forcing it to change. There are two ways radio stations modulate their carrier waves: amplitude modulation, or AM, and frequency modulation, FM. AM radio broadcasts a carrier wave that maintains a constant frequency, while the overlaying sound wave modulates its amplitude. And FM radio maintains a constant amplitude while the frequency varies based on the overlaid signal. AM and FM radio carry sound waves, a type of analog signal, to your receiver. Modern digital radio carries information as a digital signal, coded in the form of numbers. Millions of radio waves carrying sound wave signals and digital signals reach your receiver every second. The receiver's tuner picks out a specific signal. Its amplifier strengthens that signal. A demodulator separates the signal from the carrier wave. And then a speaker converts the signal to the sound waves that you hear. Finding the best way how to start a radio station can be very stressful. With so much competition and choice, you can be easily confused. From finding the right type of radio to choosing the best radio studio, there are so many things you should think of. If you want to create a successful radio station, you should read this guide. Here, you can learn basic information about the radio station and how it works. Also, you can track a step-by-step guide to get a radio license and start with emitting. Read till the end to observe how to promote your radio station, and finally, how to get money from owning it. In simple words, the radio station is an installation with physical equipment that is used for broadcasting content or having a radio connection. Radio service uses transmitters and receivers to transmit messages or information. There are different types of radio stations and they differ in technology they use for broadcasting and types of content they produce. Some of the most popular are commercial radio stations, even though internet radio communities are growing bigger every day and are becoming one of the most used forms to listen to the radio. The radio station can consist of a different number of people depending on the quality and coverage, but for the basic work, it needs additional equipment such as headphones, microphones, and computers for creating a program. No matter of location or size, every radio station should have basic equipment and program to be considered as one. Not just the device you use for transmitting radio waves makes the most important difference between radio stations. Listening to radio differs from generation to generation and it is limited to geographical position. Even though younger generations are more interested in internet formats, traditional radio is still being listened to in everyday life. Here are some of the most used forms of radio stations. Streaming/web/online. For keeping 24HR radio station, you should consider web or online streaming. This is also the best solution to avoid paying a radio license for broadcasting or buying too much equipment. The only thing you should have is a music streaming license. Web type of radio is ideal for collecting internet radio communities and sharing your music preference or ideas with people all around the world. Mainly younger public listen to internet radio using different devices, like smartphones. What is more, this is a cheap way to start with the radio business since the only equipment you need is a computer. Traditional AM/FM. Traditional radio station uses wires and air to transmit. This is the most traditional type that you can listen to from physical radio devices. With investing in devices such as transmitters and more professional equipment, you should have a license to broadcast. There are hidden costs in preparing a complete radio station, so be prepared for serious initial investment. But, this is the most widely used radio type, listened to in offices, vehicles, and in public generally. The challenge of launching remains due to your local region and possibilities to place or rent your transmitters to reach a wider public. Satellite/DAB digital. Compared to other types of radio stations, this is the most expensive option. It is mainly used in areas where are no physical transmitters. It can reach wider geographical locations, but setting the needed infrastructure can be an expensive and complicated process. Satellite radio uses satellite to transmit the signal, while DAB radio uses wide-range transmitters that can combine more radio stations and transmit them across the country. Those complex features can work only if you have enough money and experience to invest in the project. Yet, laws and rules differ from country to country and they need to be followed. Be sure that you check the legal aspect well before starting this type of radio broadcasting. What's the difference between AM and FM radio? Share. The role of radio in our society has changed dramatically over the years, but the technology behind it remains important to this day. Historically, radio was an important source of news and events, and as it became more common in households, it provided families with entertainment at home. Once TV entered the spotlight in homes, radio stations expanded their musical broadcasts and shared new music with listeners everywhere. Today, we can still hear everything from news, talk shows and sports recaps to jams old and new when we tune into our favorite radio stations, and with apps and satellite radio, we can listen in from nearly anywhere. Keep reading to learn about the difference between AM and FM radio technology and the National Inventors Hall of Fame inventors behind each one. How do AM and FM radio work? Every radio station sends out a carrier wave, or carrier signal, with variables including amplitude and frequency. When a station plays music or begins any other kind of broadcast, the sound waves are converted into electrical signals that reach our radios via the carrier wave. Depending on whether a radio station is AM, amplitude modulation, or FM, frequency modulation, the carrier wave changes either the amplitude or the frequency. In an AM radio station, the carrier wave's amplitude, or the height of the wave, changes. In an FM radio station, the frequency, or the number of wave cycles completed in a certain amount of time, changes while the amplitude stays the same. Because electrical signals can affect a carrier wave's amplitude, AM radio tends to emit more static in comparison to FM radio. FM radio also offers greater bandwidth, resulting in more nuanced sound quality. Who invented AM radio? Hall of Famer Reginald A. Fessenden was born in Quebec, Canada, and had been fascinated with the idea of wireless telegraphy from childhood. He later went to the U.S. to work with Thomas Edison and George Westinghouse. There, he investigated wireless radio communication with the U.S. Weather Bureau. On Christmas Eve 1906, Fessenden transmitted the first radio broadcast from Brant Rock Station, Massachusetts, which could be heard by ships off at sea, a song played on the violin and a passage read from the Bible. Previously, wireless broadcasts had consisted of dots and dashes used as code rather than the human voice and music Fessenden was able to share. However, with Fessenden's invention of AM radio, he put into practice the idea of mixing two high-frequency signals to carry the audible low frequency of the human voice, a major breakthrough in radio capabilities. Who invented FM radio? Born in New York City, Hall of Famer Edwin Howard Armstrong earned a degree in electrical engineering from Columbia University in 1913. While in college, he invented a regenerative circuit, the first amplifying receiver and the first reliable continuous wave transmitter. During World War I, Armstrong served in the U.S. Army Signal Corps laboratories in Paris, where he invented the superheterodyne circuit to amplify weak, high-frequency electromagnetic waves. By 1933, Armstrong had developed a solution for a static-free radio broadcast. His new system, known as wideband frequency modulation, varied radio wave frequency over a wide band of frequency rather than a narrow band. Its improved radio signals helped make FM radio a great place to hear our favorite tunes clearly. In fact, Armstrong's inventions were so impactful that every modern radio or television still makes use of one or more of his developments to this day. AM/FM radio can feel like pure magic. Switch on the radio and listen to music, talk shows, or any other audio entertainment being broadcast from a source located hundreds, if not thousands, of miles away. But radio isn't magic. It's a straightforward if fascinating process. AM stands for amplitude modulation, and FM stands for frequency modulation. Both AM and FM radio programs are transmitted over the air via radio waves, which are part of a range of electromagnetic waves that include gamma rays, X-rays, ultraviolet rays, visible light, infrared, and microwave. Electromagnetic waves are all around, everywhere, at different frequencies. Radio waves have properties similar to light waves, such as reflection, polarization, diffraction, and refraction, but radio waves exist at a frequency that your eyes aren't sensitive to. Electromagnetic waves are generated by alternating current, AC, the electrical power used to run most of the technology in your home and life, from washing machines to televisions to mobile devices. Electricity in the air is random noise. To be turned into useful signals that transmit information, music or voice, electricity must first be modulated. Therefore, modulation is the basis for AM and FM radio signals. Another word for modulation is change. Electromagnetic radiation must be modulated or changed to be useful as a radio transmission. Without modulation, a radio signal can't carry information. When it comes to radio broadcasts, the electromagnetic radiation, electricity in the air, must be modulated with the information to be sent. AM radio uses amplitude modulation, the simplest radio broadcast form. To understand amplitude modulation, think about a steady signal, or wave, broadcasting at 1000 kHz on the AM band. The constant signal's amplitude, or height, is unchanged, or unmodulated, so it doesn't carry any useful information. This steady signal produces only noise until it's modulated with information, such as voice or music. This modulation results in a change to the steady signal's amplitude strength, which increases and decreases in direct proportion to the information. Only the amplitude changes. The frequency remains constant. AM radio in the Americas operates in a range of frequencies from 520 kHz to 1710 kHz. Other countries and regions have different frequency ranges. The specific frequency is known as the carrier frequency, which is the vehicle by which the actual signal is carried from a broadcast antenna to a receiving tuner. AM radio transmits over greater distances. It has more stations in a given frequency range and can be picked up easily by receivers. But AM signals are more susceptible to noise and static interference, such as during a thunderstorm. The electricity generated by lightning produces noise spikes that AM tuners pick up. AM radio also has a limited audio range, from 200 Hz to 5 kHz, making it better for talk radio than music. For music, AM signals are of lower sound quality than FM. FM radio broadcasts. FM radio uses frequency modulation. To understand frequency modulation, consider a signal with a steady frequency and amplitude. The signal's frequency is unchanged or unmodulated, so there's no useful information contained. When you introduce information to the signal, there's a change to the frequency directly proportional to the information. When the frequency is modulated between low and high, the carrier frequency is transmitting music or voice. Only the frequency changes as a result. The amplitude remains constant the entire time. FM radio operates in the 87.5 MHz to 108.0 MHz range, a higher frequency range than AM radio. The distance range for FM transmissions is more limited than AM, usually less than 100 miles. However, FM radio is better suited for music. The higher bandwidth range of 30 Hz to 15 kHz produces the sound quality we enjoy and prefer. To have a greater coverage area, FM transmissions need additional stations to carry signals further. FM broadcasts are commonly done in stereo, a few AM stations can also broadcast stereo signals. Although FM signals are less susceptible to noise and interference, physical barriers, such as buildings and hills, can limit them and impact overall reception. This is why you can pick up certain radio stations more easily in some places than others, or why you lose stations as you drive through different areas. Thank you for watching this video.